Right, the 5-number summary, what's all that about? This extends the median and range that we looked at in a previous module one stage further. Let's just recall what median's all about. Here I've got some figures on 10 patients who've had their blood pressure measured while they were resting, which is what supine means. And as you can see, there's a range of numbers, and I've put them in order of size for you. To find the median, in this set of data, because it's 10 numbers, you have to find the middle two, and then you add them up and divide by 2. So the median is 120.5 millimeters of mercury, which is the units of blood pressure. There is a more systematic way of knowing where to find the median in a set of numbers. You basically just add 1 to the number of results, so 10 plus 1 is 11. You divide the answer by 2, and then the answer to that sum tells you the position of the median. So 10 plus 1 is 11, 11 divided by 2 is 5.5, and we interpret the 5.5th number as being halfway between the 5th and 6th number, which means that sum that we did before. So that's a way of finding the median by procedure, by recipe. When you've got like hundreds of results, you tend to use that method rather than trying to count through them and find the middle. Now, in the case with 9 patients, it still works, the same rule still works. Add 1 to the number of results, 9 plus 1 is 10. Divide the answer by 2, 10 divided by 2 is 5. Well, the 5th number is the median, and there we go. So that's kind of easy to spot when it's a small number of results, but it's quite hard when you've got hundreds. So that's the median of an odd number of results. Okay, now we're going to extend the idea. The 5 numbers is the maximum, the minimum, the median, then 2 new kinds of number. Let's have a look at those. Here's my data set again, my 10 patients. I've divided them into 2 halves, the bottom half and the top half. Bottom half's got 5 results, top half's got 5 results. The dividing line is the median, of course. We can find the median of the bottom half. That's quite easy. 5 plus 1 is 6, divide 6 by 2 is 3, it's the 3rd number. We can also find the median of the top half. Same principle, 3rd number on the top half. Those are actually given names. They're called the quartiles. Why quartile? Because those numbers divide the data set into quarters, if you think about it. So the lower quartile, 25% of the results are less than that or equal to it, and 75% of the results are larger. The 122 millimeters of mercury is the upper quartile. So that's where 75% of people are less and 25% of people are more. Now, those values are pretty stable. Suppose we had somebody with massive hypertension included in this group and they had an enormous systolic blood pressure. That wouldn't affect the quartiles that much, but it would affect the maximum in the data set quite a lot. We'll come back to that later on. So to label up my numbers, I've got my lower quartile, my median and my upper quartile, and we can of course include the minimum and the maximum, and that's your 5-number summary. So to recap, you've got the minimum value, the maximum value, you've got the lower quartile and the upper quartile, and you've got the median. See how the quartiles have 2 different kind of abbreviations. LQ and UQ are the common sense ones that you'll find in most GCSE textbooks. More advanced textbooks tend to use Q1 and Q3. Q1 is the 1st quartile and Q3 is the 3rd quartile. Logically, the median is actually the 2nd quartile, and you may manage to find a book that refers to it as that, but it's very unusual. Now, here's one for your turn. Even number of data items. Heights of children. Just stop the video, take a couple of seconds and see if you can work it out. Again, I've put the numbers in order of size for you. Okay, I got 156 and 157 because it's an even number of data sets, even number of results. Then I add those up. Oh, my lower quartile was 153, my upper quartile was 163, and I pressed the button too quick and got 2 slides at once. And my bottom number was 144, and my top number was 172. The median is actually 156.5 because it's halfway between the 2 data items. Halfway between the 2 data values because it's an even number of data. Okay, now we do have a problem. What happens when you start off with an odd number of values? What do you do about the median? There are two. Let's have a look at a data set here with an odd number of results in it. It's actually got 13 heights, okay, of children. Now, the median is 13 plus 1 divided by 2, the 7th number in the list, so it's 156. Some textbooks will find the quartiles by excluding the median. They'll define the bottom half and they'll define the top half. The bottom half in that definition has 6 numbers, so the median of the bottom half, or the lower quartile of the whole data set, will be the average, the mean, of the third and fourth numbers. In fact, they're actually both the same, so it'll be 153 centimetres. The median of the top half will equally be halfway between 163 and 163, so that's going to be 163, because by sheer coincidence in this data set they happen to be the same numbers. Okay, now the other convention that some other textbooks use is to include the median in both data sets. That's actually the convention that I'm going to use, because it helps when you've got quite small data sets. It helps even things out a bit. The difference between that and the other method gets less important when you've got large data sets. So now the bottom half has 7 numbers in it, so the median is the 4th number, and that's 153. And the top half has 7 numbers in it, and the median of that one is 163. Interpreting the 5-number summary, just a few suggestions. What does it all mean? We'll spend a lot more time on this later on. Well, here's the summary for the height data set you've just seen. Here's a little table organised with the 5 numbers in it. The first thing you can do is work out the range. The range is the max minus the minimum value, which I make to be 24 centimetres. That's quite unstable. It would only take our 168 centimetre child to be replaced by a basketball player of 200 centimetres, and that range figure would double. So that's not a particularly good measure of how spread out your data is. A better one has the resplendent title of interquartile range. So that's the difference between the third quartile and the first quartile. Range is always used in statistics to mean the difference between a large and a small number. So that one is 10 centimetres. And that's a much more stable measurement. You can add quite a few basketball players before the upper quartile starts to change. So that's a more meaningful measure of how spread out your data is. It's also easier to visualise because the range, if you like, between the upper quartile and lower quartile includes the middle half of your group. So you know that the middle half of your group varies by 10 centimetres. Now the median is 156. That's a pretty typical result. That's a good typical result for your data. But notice how it's much nearer to the first quartile than it is to the third quartile, Q3, the upper quartile. That tells you something about the shape of the distribution of the heights. Now, later on, we're going to look at something called the box and whisker plot. That thing that looks a bit like a hypodermic syringe is called a box and whisker plot. As you might have guessed, the lines on the outer part of the diagram, the two vertical lines at just about 144 and just about 168, are the minimum and the maximum. The box in the middle, the red box, the lower part of the red box is the first quartile. The end of the red box is the upper quartile or third quartile, and the line in the middle is the median. That's a very simple visual representation of the distribution of your data. We'll look at drawing one of those in a bit. Your turn. Now, I want you to go and find a data set with 12 or 16 or some other multiple of 4 values and find the 5-number summary. You'll see what I'm on about when you do it. Then find a data set with an even number of results which has an odd number in each half, and then find the 5-number summary of that one. And then finally, if you're in for a challenge, can you make up a data set? Just get a spreadsheet and make one up with 12 numbers where the median is exactly twice the mean. Okay.